Oh, yeah. Good. Yeah. So as I was saying, the last time or a little conversation that we had, I sensed that most persons in the class, they haven't done physics before, right? And sometimes, what we hear about the subject and so can be scary, right? And I think sometimes we fuel the whole that fear, that this thing is hard and so sometimes by what we watch and so. For example, how many of you probably watch Big Bang Theory? Anybody ever watch the show?
Yes, sir.
Yes,
I
sir.
Yes,
don't really
sir.
watch it
Yes,
much.
sir.
Yes,
Not
sir.
I've
I've
seen
seen
an
it.
everything.
episode. Yeah,
Few episodes.
and the funny thing you notice in that little series, right? It's a sitcom. Is that they always picture physicists, right? Like what is guy name? Sheldon is his name, and his other friends, very geeky and so. Um, but when you listen to the stuff that they say and so, they seem to put down everybody else, and they think that they're the smartest in the room and all of that, right? And of course, you from the person from the outside, you look at the whole thing and you realize how stupid they are and all of that, right? Um, but lots of times people are very fearful. They have this thing that to be a physicist, you have to have extraordinary genius and all of that, right? You have to be gifted or something, and that might not very well be true. Um, so a lot of people when they hear physics, they start to get scared. As a matter of fact, and by the way, you might be wondering why I don't get straight into the course outline, right? And I don't want to get straight into course outline and start with any heavy physics and all of that. And we're gonna ease into the course. You bear with me, right? Because if you want to do physics, we can do physics right away, right? And get into the hard stuff right away. But I always believe you walk into the gym, you don't go pick up the heaviest weight, right? So, some of these boys in the class, they like to do that to impress girls. But lots of time when I pick up the weight, something feel a little funny in the pants. Right? You don't go in the gym and pick up the heaviest weight. If, you go in there and you take a look around and you know, then you get to stretching and so. And after you have done a lot of stretching and loosening up the muscles and so, waking up the bones, then you go and you probably start with some very light weights and you kind of warm up the muscles and so on. Then you build up to the really heavy stuff. Is that what you do, boys? Anybody in this class? You do weight training or you'd go to the gym and so? Boys, girls, anybody?
I'm planning to, sir. We're planning to.
Yes, sir.
Um,
That's the way.
okay, he's planning to. It's a big thing here. They have 2 or 3 gyms in my area here, and you wouldn't believe me when you go if you go there now. There's no parking. Parking is the biggest, and I live Palmyra, right? If you see people, and I think all of them go to the gym too. I think it's a social place. They go look for nice boys, nice girls, and physique and all of them. Because when I see how they're dressed and whatnot, I don't think they're going there to exercise. But if you see people there, yeah, yeah. So yes, you want to ease it up. You're going to ease into physics. Don't worry. Yeah. So I want you to get a little idea of what it's all about and all of that, right? And of course, if you were to Google, if you were to Google um, a little definition of physics, right? Of course, the internet can give you thousands of definitions, right? And all of them, they'll have their merits, their demerits, and so. But they'll give you the basic idea, that what physics is all about, right? And basically, it's that branch of the sciences, right? Where you're studying the properties of matter and energy, right? And some big areas in physics are areas like mechanics, right? And these deal with you're studying a lot about forces and you study about um, you look at forces, you look at forces are there's so many of them too, right? You got frictional force, you got forces, you got uh, you got if the weight is a force by itself, right? You got all kinds of different forces and how they act, right? And you learn about turning forces, turning forces, right? Um, you learn about acceleration due to gravity, all kinds of things, in mechanics, because mechanics got to do with how forces interact with one another, and sometimes these forces can be in equilibrium. That's a big word they use there. I'm not gonna get into any. I'm just awakening you, to some things and then sometimes you have non-equilibrium, meaning, um, well, the forces don't equilibrium, right? And the forces don't, um, counteract one another or cancel one another out. I should be careful of that word cancel. Um, but there's no net force. There is a net force, sorry, acting, and then the body starts to move, and there's where acceleration comes in or motion comes in, right? And so mechanics is concerned with that, right? How forces act on a body, right? And mechanics can very well get into things like pressure as well. Pressure, we could talk about all of this, right? Pressure, and we can talk about density, all of these things, right? So that's one area of physics. Then, of course, there's a whole big area. I'm going to use a simple word, heat, right? You hear thermodynamics instead. Thermodynamics, right? And I got to do with, this heat and internal energy, and how that affects the behavior of matter, right? Big area in physics is also light, right? Study of light, right? And not light as a whole, but waves, right? Waves, and there's so many types of waves, electromagnetic waves, sound waves, right? All of those things. Um, and there's electricity, all these are different areas of physics, right? And then there's what we call nuclear physics as well, right? Nuclear physics. This got to do with the study of the atom and its behavior, right? And all of you know that's a really big thing where um, they actually explore how they can extract energy from what we call radioactive substances and so, right? And so physics basically is that we're looking at properties of matter and energy, right? And as I said, these are some areas: mechanics, heat, light, sound, electricity. I didn't mention magnetism, right? And then a big branch of physics, and I think that's a more modern, um, it's a more modern topic in physics. This matter of nuclear physics, right? Where they study um, these um, these elements that are radioactive, right? And how they can give us energy and all of that, right? Um, so as a matter of fact, those I did hear some of you said you worked in a medical area, like nurses and so. Is there any X-ray technician? X-ray technician among us? Nobody? Okay, nobody does like ultrasound. Anybody does ultrasound? Ultrasound, X-ray. Now they have CT scans. Anybody work in those areas? Like, I mean, they might be assisting whoever doing those things. Nobody?
No, sir.
No, sir.
Okay, okay. Because especially when we're going to get into real occupational, health and safety, um, those people who work, especially with X-rays and these scans and so, um, they have to take so much more extra precautions. Huh? Lots of times you hear people don't stay on those jobs for very long, especially like an X-ray technician. You know, you want to think about, especially girls and their reproductive health, and so there are lots of questions raised about them. Yeah. Um, I was going to talk about um, how they actually produce X-rays and so on, how it's such a dangerous thing to be constantly exposed to it, right? Even ultrasound, I mean, while it's safe, but here there's nothing that we want to get exposed to too much. Nothing. Whether be
Sir,
it
would
good
that,
food, okay? Huh?
I was just
Yes.
wondering if that somehow applies to the scanners at airports
Certainly,
that you would have to
yes.
go through.
Yes,
Oh,
yes. Right. Look, these I mean, you don't go through that every day. You aren't a passenger, right?
I work at
Uh,
the airport, so I have to go through there every day, several times a day.
what?
Yes, sir. It
Okay.
depends on your job because I worked in aviation as well, and we would opt
Uh-huh.
to take in the pat down
Yeah.
unless we like die hard have to go through the scanners when it comes to women. Yeah.
Well, yes. Well, look at that. I like that. I like that you have a choice where you can take a pat down, right? Maybe a female, if you're a female pat you down,
We
or if you're a male,
we
have a
don't
male pat you down.
we don't
Sir,
have that
some
option.
ports,
We
not
don't
all,
have that
not
option
Guyana.
at CJI. We have to go through the scanner. It's mandatory. We
Yeah,
Oh
have to
in
go
my.
Guyana you have to.
unless you're pregnant, then you have the option to walk aside from the scanner. Other than that, you have to go through the scanner.
Oh, yes, 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 yes. Yes. Well, oh, and these are things these are more like what you call union matters, where your union and so is supposed to get involved with how much of this is safe and all of that. You see, for a passenger, how often does somebody fly? You know? But if you have to go through that every single day, right? You might want to ensure you research it properly, right? Because I mean, everywhere they're interested in your service and your labor and what you can give. But let's say something go wrong because of the job, what happens, right? Very often, you sometimes because of the legal, or I would say the legal procedure to get compensation is another. Look, I'll tell you this: I have psoriasis, right? And I cannot prove that it was caused by my working at the. I work with Gaisuku and I work with chemicals, right, for a number of years, right? And because I really understood chemicals and how they work and what will work where, and so they kept me for a long time, more than 2 years. They kept me right in a department where I had to deal with chemicals and supervise people spraying chemicals. And I didn't develop psoriasis right away. It was when I left the job I developed it, right? I couldn't prove it, you see. So here, I have the suspicion that it's connected to my exposure to chemical for a prolonged period of time, right? But the thing didn't happen right away, and now I have psoriasis for over, let me see, about nearly 25 years, right? Since I left that job, right? I left Gaisuku and started to work at teaching, right? Yeah, so sometimes that's the thing. You have to look after yourself, right? While you're thinking of earning a living and so. You don't want something, you are exposed to something every day, right? And it has some adverse effect on you, right? Whether your reproductive health, just this computer, watching this computer, blue light. There's so much research now about the light that comes from the computer and its effect on us. One of the most recent effects that I am telling you this because I have known a number of people who are complaining of mental issues, right? Mental issues because of overexposure and sitting here, just sometimes not the light alone, but sitting here and interacting with, people virtually. Lots of things happen to us, right? COVID, I can tell you this. One of these days when I put on back the camera, I'll show you all. I developed a craning of the neck, like a curvature of my spine. And my workplace doesn't care now because they don't care. But during COVID, because I've been teaching for the two odd years that I was home, teaching with using the computer. As a matter of fact, until now, right? Most of I taught I'm teaching 11 courses this semester. You believe that? 11 courses. And most of them, if not all, I'm teaching through the computer. So I've developed a terrible problem with my neck. I can't turn my neck to the right, to the left. I can't look up to the skies anymore. If you see me in real life, if anybody here is from my area, you'll see that I have a serious problem in my spine. I have difficulty driving and all of that. So when it comes to we talk about, it's good we're talking about occupational health and safety, right? These are important things, right? And if there's like I know Eugene, we do have a occupational health and safety office, right? Where we can complain and all of that. But they're paid by the university, so how much will they care for you? Right? You understand? And sometimes your union too, you want to get involved so that your environment is safe, All right. So we said we're not going to get into the health and safety part so quick, but we're gonna let's deal with physics a little. Yeah. So basically physics, deal with these areas. And I think your course is going to touch on a little bit of mechanics, a little bit of heat, light, electricity, just for you to get a feel of physics and how you see it in your workplace, your life, right? And understanding certain things and how things work can really help you, right? And to ensure that you work safely. And you can even extend that to home, right? To your home and the way you live your daily lives, so that in no way you cause harm to yourself, to others who work with you or your family, So physics, yes, it does have a bearing on occupational health and safety, your general well-being, right? I would say all the sciences, right? It's good for you to have a little bit of understanding of chemistry, how things work, how chemicals operate, right? Lots of times, I'm not deviating too much. I'm just telling you, you don't know. You might be at work. I remember when I used to work with Daisuku. Sometimes the estate wants to cut back and so, right? But they used to give you, they had a place where you shower after you work with chemicals. You shower and they have to give you soap. Sometimes they want to cut back. They don't want to give you soap. So here you have to go and bathe, and sometimes water don't really take out those chemicals, right? So when you wear around back your civilian clothes now and you go home, what happens? You take the chemical home. You can harm the family. I remember one time when we sprayed certain chemicals, they used to give you milk. Again, to cut back on costs, they stopped giving you the milk. because there's this belief that milk combines with certain toxins in your stomach and so on. It can help to flush them out, right? It's one of the beliefs they had. Whether it's firmly grounded in science, I'm not sure, right? They stopped because why? Well, it's cost for them, right? You know, Gaisuku was making a terrible loss at the time. Yeah, so sometimes um, it's good for you to understand a little bit about chemicals and how they operate, right? And how they react um, with your body, right? And even well, of course, biology, you know, and an understanding of human physiology and how the body works. And so very important, because it's all connected to both your safety on the job as well as your general well-being, right? So yes, so this is a little bit about what physics is all about, right? As we said, it's basically we're studying the properties of matter, why matter behaves the way it does, right? And we will extend it to, okay, if matter and energy and so behaves this way, well then for us to keep ourselves safe on the job, we have to understand, we have to respect it, we have to handle these things in a way that, well, we are not harmed, we don't harm anyone, right? And even at home, as I said, your general well-being, you and your family, well, you can be able to live safe lives, you know, right? For example, I remember when I when I went on a job at the Gaisuku, and I was working with the electrical workshop for a while, and there's a big sign. What you see, what you can't see can kill you. And you know what they're talking about? Electricity, right? Understanding electricity, right? You understand, if you understand the workings of DC and AC current and so, right? You can be able to handle these things. You can work with electricity and not be harmed, right? So yeah, it's good for you to get a basic understanding. You don't have to get into the deep physics and the heavy mathematics, but as the course says, basic physics is enough for you, right? Good. So I just want to go over now to, and this is the first thing on our course outline. Anytime you feel you want to interject and contribute to the class, that's not a problem, right? You can always, you know, interrupt me and share. That's not a problem, right? Yeah. So one of the thing about physics is that we try to measure the physical quantities of matter, right? That's our intention, really. We want to quantify everything, right? We can quantify everything. If we can quantify, right? So what we try to do in physics, as we said, is we try to measure the physical quantities. And I said before, when we speak about physical quantities, you know, it's the quantities we can see, we can touch, right? And we can get an instrument that can measure that physical quantity, right? And if you were to go back to the notes that I sent you, right? Some of these physical quantities got to do with, all right, maybe distance or length, right? That's a physical quantity. There's an instrument. I mean, all of you know, depending on what we're measuring, if it's big or small, right? What do we measure length with? Anybody? What instruments we use? What instruments we use?
Sir, ruler.
Yeah, simple ruler. Yeah, a ruler, right? And that's for short lengths, right? What else we use? This is an R, right? It's RU.
Measuring tape.
Okay, a measuring tape. Yes, a measuring tape, right? A measuring tape. And these are, I think, I was asking a question the other night. You people said tape measure, right? I guess they don't want this ing piece here. It's a tape measure. For whatever reason, there's an old story how they say tape measure rather than measuring tape. Yeah. And these are short distances, right? Or lengths. You measure with this. But if you want to measure very, very small lengths or distances, right? Like okay, you have a small like a bearing, a ball bearing, and you want to measure this, right? They have what you call they have some things called vernier caliper, right? You have something called a micrometer, right? Some people say the micrometer, screw gauge, right? So for very small things, right? Small lengths, you might use an instrument that, has that capability. For this, it might be, when I say a ruler measuring tape, you're talking about in the range of maybe a couple of inches or feet, it would work, right? But then if you want to deal with very, very small things, maybe you have to use one of these, right? And then for very large distances, right? We're building a lot of roads. We're building a lot of roads in this country. And you ever see them guys walking around with a thing like a wheel? And they roll it around?
Yes, sir.
Okay, let's say the
Or the
contractor.
surveyor's wheel.
Oh, that's what they call it? I think they call it, what is it? Odometer? Is it that? Is that it? I think they roll it, and I think, let's say, okay, the wheel has a circumference of 1 meter, right? And there's like, okay, there's some kind of little projection on the wheel, and there is what you call like a counter on it. So every time the wheel goes around one time, it turns that counter and it registers, let's say, 001. Then when it goes around another time, it turns this little projection on the counter, and then it goes to 002 and so on. And that's how they measure. Like if they want to measure 100 meters, you wouldn't have a measuring tape to do that, right? You can't take a ruler and measure 100 meters, And then of course you have larger distances, like you're talking about between, okay, let's say from here to Skeldon. Well, I live in New Amsterdam, Palmyra area, right? So from here to Skeldon, let's say it's 70 km or roughly 50 miles, right? To measure distance like that, well, of course, all of these will fail now, right? All of these will fail, and you have to find some other way, right, of measuring it. So, and then scientists have been trying to measure distance from here to the moon, from here to Mars, from here to the sun. It's interesting to know how they measure those. But again, I don't want to scare you, right? That's the heavier physics. I just want to introduce you to some physical quantities, right? We talk about length. I think the notes talk about mass is another physical quantity, Oh, before I leave off length, let me name a few of them. We'll talk about units just now. Time. Time is another physical quantity, right? I think they have electric current. Did you see that in the notes? Temperature. Let's see, let's erase some of these things. Anybody want to add to that list I have there?
There is also amount of substance and luminous intensity.
Very good. I like that you're looking the notes and so nice. At least I didn't send you stuff and nobody didn't take the time to read anything and so, right? There's a very involved, there was a set of notes there that it's very detailed and goes into a lot of stuff, but then there's some notes there that you can quickly get some main points from it. Yes, temperature. Temperature was mentioned. Then we have, somebody said, amount of substance. Amount of substance. What's this? Amount of substance, and then luminous intensity. Intensity, yeah. Right? So these here, what they call them is they call them the fundamental, and don't be scared by the word. It just means the basic physical quantities. Right? They use, I think they said the word, they are dimensionally independent. What they mean is they don't depend on anything else, right? And you'll see when we talk about what we call derived quantities, how those are dependent on these, right? So these are called the basic or the fundamental physical quantities, right? And these are quantities, remember, when we talk about the fundamental physical quantities, right? They're quantities that we can, measure. There's some instrument to measure it easily, right? So all physical quantities, basically, there's some way of measuring them, right? There's some way of measuring them. The fundamental ones we're saying that these are basic ones, right? These can be measured directly. The others can, well, of course, there are instruments to even measure the derived ones, right? We've been able to do that, right? We have been able to even make instruments that can measure almost any physical quantity, right? That we know of, right? And that we use in understanding the properties of matter and energy and so forces and so, right? But these are the basic ones. Think how many of them? 7 of them? 3 and 3, 6, 7. Yes. Good. So these are the quantities.
Sir, can you pronounce the last one?
Luminous intensity. Oh, I didn't write it nice, no? I have horrible handwriting. Luminous intensity. I'll tell you what it is just now. Good. So the next problem is, okay, we identify these as, okay, they're properties or their quantities to be measured, but then we have to settle the matter of, well, how do we measure them, right? And when we measure them, okay, that's instrumentation coming in there. We have to find an instrument to measure them. And then when we finish with that now, we have to worry about, well, we have to create a unit of measurement, right? And one that is standardized. I think in the notes, mention is made of standardizing. And let me tell you a little story, right? Long ago, it's a funny story. Do you know how much was a yard long ago? You ever heard a story? How much is a yard? How they used to measure a yard?
No, sir.
Oh my, hear this joke. This is more than a joke.
Pull it with your hands, sir.
Say it
Turn it with
again.
your hand. From one end to one end with your hand.
Pull it with your hand.
All right, you're close. All of you are close.
Like these.
Is that from
This one
shoulder
time.
to wrist or something?
One time, I think it was from the middle of your chest, right? Not you. It was the length from the king's chest, in the middle of his rib cage to the tip of his finger. I think that's a joke. I don't think that it's really true, but legend has it, or the story says that at one time, the length from the center of the king's rib cage to the tip of his finger was 1 yard. And you read that a lot in the textbook. And don't believe a lot of these stories, right? Don't believe every one of them. A lot of it is just to entertain you, right? Why I say that is I cannot believe that we were that low where That was the standard. That you have a short king and you got short hands, and everybody here. I guess a yard of cloth or a yard of rope at that time would be very short. Well, when you have a long king or a tall king, sorry, long limbs, well, what happens? And that's why we need to have what you call standardization, right? That is not a good standard, right, for length, right? As a matter of fact, all the other the quantities, you have to have a good standard, right? It must be dependable, right? It must be dependable, consistent. I think the note says it must be globally standardized, meaning a yard in Guyana must be the same, must be a yard in India or Africa. 1 yard must be 1 yard. 1 kilogram must be 1 kilogram everywhere. There was that need, and that's why they came up with what we call SI units. SI units, right? The Système International, right, units, or the International System of Units. And they standardize the units for these quantities, right? So like the length, well, as I said, we have a lot of instruments that we can use to measure length. But they said, look, the standard unit is going to be the meter, right? And in the notes, I think the mention was made how they define the meter. It wasn't always like that, right? At one time, they had decided that, okay, they had a length of a rod, right? I think, I can't remember what it was made of. It was made of a metal that don't corrode easily and don't expand and contract too much under different temperatures, right? And that was their standard for a while. But now they defined the 1 meter differently. I think it has to do with how many times. Let me see. What do they have it? Okay, I think the note says the distance light travels in a vacuum in 1 over 299, 792, 458 of a second. One horrible number there. Yeah, so they're trying to standardize it, in a way that it mustn't change. The distance light travels in a vacuum in Guyana is the same everywhere around the whole world, right? But they try. You don't have to know the definition of the meter like that, right? Don't kill yourself and memorize something like that. What I want to illustrate to you is that there was a need to standardize what 1 meter, when I say 1 meter, what it means, right? So yes, the meter became the standard unit, right, for length. We're going to go just now into what we call multiples and submultiples of the meter. Like if you're dealing with a very small, maybe I can talk about it here, very, very small length, right? Maybe the thickness of a pipe, right? You might want to use mm, which is millimeters, right? Millimeters, right? I know the Americans spell it METERS, but the British spell it METRES, right? Yeah. So maybe a small distance, you might use millimeters, right? Like the size of a ball bearing, the thickness of a pipe. But then very large distances, right? Like you're talking from here to Skeldon. Well, you might want to use kilometers, right? Kilometers, right? So maybe from here to Georgetown, it might be 100 kilometers, So you might use that. And then there are some other multiples and submultiples. We'll get to them a little later. I don't want to, burden you. Am I being too difficult?
No, sir.
All right.
No,
Good.
sir.
Let's go on to mass now. Mass, the standard unit or the SI unit, The SI unit for mass is the kilogram, right? And again, there are multiples and submultiples of the kilogram, like you have grams, right? Let's say you're throwing salt in your food. You wouldn't measure it in kilograms. Say, man, how I'm making cook-up rice, how much salt do I throw in? And you probably would throw in 5 grams of salt, right? You wouldn't measure this in kilograms because kilograms is more suited for maybe when you're buying, okay, potatoes, you're buying meat. You wouldn't go and buy 5 grams of meat, right? You wouldn't go buy 5 grams of potato. You'd probably buy 5 kilograms of potato, right? So it depends on what you're measuring. And we're going to talk a little about that just now. Time, again, seconds, right? That's the unit. You measure time in seconds, but then again, depending on what you're measuring, right? If you talk about, okay, how long it takes for you to blink, right? Well, you might talk about milliseconds, right? Or if you want to talk about how fast you can put on a switch, yeah, maybe that can be done in a second or two, right? Or how long a website takes to load, that can very well be measured in seconds. But then you talk about, well, how long somebody lives, that can be, wouldn't measure it in seconds, but what you call a multiple of seconds, right? And you might be talking about what you call minute, hours, years, all of those are multiples of the second. The unit for time is a little peculiar. We'll come back to it a little later, right? Apart from meters and kilogram and so on. We're going to come to that. Electric current, the ampere, right? Ampere. That's the unit for electric current. And again, if you're talking about, depending on what you're talking about, when you're dealing with electronics, very, very small currents that like your computer, your phone. When you look inside a phone, if you see how the tracks and the little connections are so small, the current through there is in milliamperes, right? Even microamperes, right? Because it's very, very small. And we're going to understand what those words mean a little later. But when you're talking about, let's say you have a business and you have air conditioning, right? Air conditioning, because of the amount of power that is required to run an air conditioning, the current flowing through those wires is very, very large, right? You can talk about 100 ampere, 200 ampere, right? Very large amounts. This could kill a man. Right? And we can get eventually to the safety part of the whole thing, right? Later on when we talk about current and so. And then temperature. This one might be very strange to some. The Kelvin. Everybody is used to degrees Celsius, degrees Fahrenheit, right? But few people will really use this. When you listen to the weather, right? Like right now, my computer screen is saying it's 80 degrees Fahrenheit, 80 degrees with a little degree sign on top. Like you get 80 degrees and you get a capital F, right? Some persons would usually set this to let it not read Fahrenheit, because in Guyana here, we don't usually use Fahrenheit. We use degrees Celsius, right? You might say, man, now is around 30 degrees Celsius, right? But the SI unit, or the standard unit, is the Kelvin. And we'll talk about its relationship to the degrees Celsius and degrees Fahrenheit a little later. Good. This one here is, I don't think it will concern you much, right? It's called the mole. The unit is the mole. It's MOLE, but the shortened form is MOL, right? MOL. I'll come back to this in just a moment. I'll come back to this in just a moment. Let me see if I need some more space. That's why. Come back to that. Let me just make some space back here. Are you hearing my fan making an annoying noise? Or it's
No,
not
sir.
disturbing you?
No, sir.
Oh, great. I bought a fan from a store. I wouldn't call the store name. I shop there a lot. I'm good friends with the people. But the fan came home and it never really, it's not giving me the kind of speed like the other one I have in the house. But I didn't take it back because I've been a faithful customer there and I know the people. I kept it. I use it. I'm in my backyard here in my storeroom.
Sorry,
So
try measuring the amount of voltage that is going to the fan that would probably affect its speed.
yes, I did. I actually use this fan in the same point that I have my other fan. And my other fan, which is an identical brand, the Lasco, spins about 4 times as fast. But this fan, something is wrong with it. It's a faulty fan they gave. But again, I can't really carry back and say and prove to them that, well, it didn't happen with me. So I didn't, want to fight them and so. Because they're good people. I know them. Sometimes it's a loss that they'll have to take. And I went there one time. I needed a receipt. I bought a TV, I think. Those times you had to, for you to get a certain money from UG, you had to get a certain receipt. And the date I bought it, it wasn't the right date. And so I asked them, and they did it for me, even, so sometimes loyalty and that sort of thing it goes a far way, I didn't even go and tell them. I went in the other day. I didn't tell them, man, the fan y'all give me is no good. I didn't tell them that. I left it, Anyway, yeah, back to mole, right? When you talk about amount of substance, it's really talking about, there is a thing, right? That, okay, let's say you talk about the element hydrogen, right? Hydrogen. What they say is that the atomic number of hydrogen is 2, right? It's 2. Well, it's not. Remember, hydrogen don't exist on its own, like one hydrogen atom. They usually bind and form a molecule of hydrogen, right? H2. So the atomic number is 2 because, well, it's two hydrogen atoms joined up together. So what they're saying is that in 2 grams of hydrogen, there are, what is it, 6.02? I think there's a 3 here times 10 to the 23. Maybe you can Google this and see. They're saying that there are 6.023 by 10 to the 23 hydrogen molecules in 2 grams of hydrogen. That's what they're saying.
Sir, is that the Avogadro's constant?
Very good. Yes, must say, man. Y'all tell me lies, I think y'all know a lot of physics. Y'all know a lot, man. The interaction I'm getting from you, I'm rather impressed. I think I might have to write another A-grade report for this class. One of my classes did very well, and they told me I have to write A-grade report. The students did the work, man, and they did well. What do you want me to do? Right? Tell them no, they can't get an A. If you do the work, you get an A. What do you want me to do? The students, Yeah. Yes, back to, yeah. So I'm saying that when we talk about amount of substance, that's what they're referring to. And you might be surprised, right? Oh, by the way, let me just tell you. somebody said they were a nurse, right? They were a nurse in this class. Let me move away this a little. Do you know those glucose meters? Glucose meters. They got some that measures the glucose content of your blood in grams per deciliter. And they got some that measures it in mole per deciliter. Anybody, any nurse in the class who remember this?
Yes, sir.
Like you
Yes,
have
sir.
100 grams
It
per
have
deciliter.
mg/dl.
Yes, right? And you can, what if you can, somebody convert 100 grams per deciliter to moles per deciliter. Let me do it quick and see. How much is that? 100 mole per deciliter to grams per deciliter. Okay, so 100 moles per deciliter is approximately, they say, 161, or the 0.1 grams. Sorry, what am I saying? 100 moles. I get this wrong. 100 moles per deciliter is approximately 161 grams per deciliter. So yes, mole is being used in our everyday, especially if your nurses or doctors and so, right? This is your sugar level I'm talking about. If you're a diabetic, I don't know if there's any in the class, you don't have to say if you don't want to say, right? So this is something you use every day in your work, right? Some meters can switch from mole to grams, some can't switch, right? My wife is a diabetic and she has both of the meters. And we have a little chart that converts quickly, right? So you know it's high or low, because a lot of people are used to grams per deciliter. So when they hear about moles per deciliter, well, they don't know what that means, right? But basically, again, there's a conversion depend on what you call the atomic weight of the glucose molecule. The glucose molecule. And maybe you could, if somebody wants to research it, feel free, right? So that meter will say how much moles, right? And remember I said moles is related to grams, right? And the little instrument that you measure glucose level can give you either of the two, right? And this is very important for those who are diabetics, and so you have to monitor these numbers, right? So again, I mean, if we're talking about health and safety, right, and your general well-being, especially when you're up in age. I mean, all of you are young people. Anyway, young people getting diabetes a lot now too. You know, if you're sitting down all the time when you work, and so, and you're eating a lot of sugars and you're having a lot of spikes. You know, we have a tendency now to do a lot of snacking and drinking a lot of sweet drinks and so, right? So because of our body not being able to deal with all these spikes, and so we can start to develop diabetes. I think there's type 1, type 2. I guess the nurses will tell us better which one is the one that you develop because of bad eating habits, right? Whereas the one that is more genetic, you might not have so much control over that. But it always comes back to diet and lifestyle as a whole, you know? So this whole thing of mole and grams per deciliter is an important thing for diabetics and so, right? Other than that, a lot of chemistry people make use of that, right? Those who are into maybe working with chemicals and so, right? if you work with a place where they make like bleach and so, or you don't have to be making the bleach, because most of the time what we do, we buy concentrated bleach and we dilute it, right? You might have to have an understanding of mole and so how much bleach, how much of one particular we call it concentration must be mixed with how much, if it's water you're mixing it with, how much water must be poured into that concentration to bring it to the right level that it doesn't harm people's skin and so, right? I find I don't know if any one of you is working with like those agencies that regulate food. That is an area in this country that needs attention, right? I'll tell you why. Give you a quick story. I had a friend, I'm not going to call his name. He's a manufacturer. He manufactures food, right? I shouldn't say he processes food. He grinds stuff and makes stuff, you know. So one day he had some children who used to come to my lessons and so. This is many, many years ago, right? And he came to me, he said, man, he wants to start selling vinegar. So you buy the concentrated vinegar, but then you have to dilute it, right? So he came to me, he said, man, you know the chemistry of how to dilute this thing. So I was giving him, because at that time I was teaching high school, no bit of chemistry and so. And I was kind of telling him and so, right? And the chemistry was beating him, right? So I gave him an estimate of how much water to throw in the thing, right? But that's a bad estimate. You got to remember, he's going to go on. The people who are working with him are some people from the village who have no training in chemistry. They take the 5-gallon container and say, "I'm pouring another 5-gallon there." You know, they do things without precise measurement. So you might very well, he might be selling a bleach, sorry, vinegar. Vinegar, did I say vinegar? Yeah. He might be selling a vinegar that might be too concentrated, or on the other hand, too dilute, right? And if it's too diluted, what happens? You are using vinegar to say, let's say you're washing meat. You know, you bring the chicken and you know the chicken is full of salmonella and you think that the bleach is doing its work, but guess what? The bleach isn't doing nothing because the concentration is wrong. On the other hand, you know, if the did I say bleach? I meant vinegar, right?
Sir, I tried
Yeah.
to figure out.
Yeah, sorry, why am I mixing up bleach and vinegar? I'm talking about vinegar. So you buy this white vinegar, you want to wash your chicken, you want to wash your meat with it or fish or what. If the vinegar the concentration is too low, it's not going to do its job and you get poisoned. If you're into catering, you poison people. You understand? People take in and you don't know that by your barbecue or whatever you sell and harm them, right? So then on the other hand, if the vinegar is too strong, it can harm you. It can harm your skin, right? You eat the food and it can harm your inside, you know, depending on the concentration. Next thing you know, your whole mouth burning, you want to know what's going on, right? Cause damage. So these things are important. I remember he also said he wants to get into like pepper sauce and all of that, right? And he bought sodium benzoate somewhere in Georgetown, selling it by bulk. And not him alone. I had another friend who was selling coconut water. And he says, man, people are able to hold the coconut in their mouth and so he wants to bottle it. But then sometimes they fill up about 20, 30 bottles in a day and people didn't buy out all. And by the next day it's spoiled. So they're buying sodium benzoate and throw it inside. So I said, how much are you throwing? You gotta know. You gotta know how much. People don't do all of that, they just throw in. You put a little bit, man. Little bit is not that's not science. You gotta know the safe amount because sodium benzoate, one of the underlying or the basic element in sodium benzoate, as it sounds, is benzene. Probably you heard of a benzene. Benzene is very carcinogenic. It causes cancer in the human body. That has been proven, right? So you see how we like, all of us like to eat a lot of thin stuff. For the food to be preserved, a lot of food have sodium benzoate inside. That's why half of America get cancer, because They don't get fresh food. They depend on preserved food, which has sodium benzoate, right? Apart from other things, right? America, they live in an environment that is so carcinogenic. Too many things can cause cancer for them. And Guyana is getting like that. Most of you don't like to eat fresh food. You like a packet thing. You like a packet thing. Everything coming from packet. All kinds of chemicals and coloring and so they in the thing just to give it color. And those can be harmful to you. Anyway, I deviated too much there. Yeah. So yes, this kind of thing is important. This thing of mole, right? Those who are into chemistry, this is a quantity that is going to interest you a whole lot, right? And then last, somebody asked me about luminous intensity, right? And this got to do with brightness of light, the brightness of a light source, right? And this is important. This is very important. We talk about occupational health and safety, right? And your well-being and so. Let's say you're working in a factory. I mean, you're working among with machines and so. If the light isn't bright enough, you're not going to see what's going on, right? If the nurse is working let's say in the ward or in an office where the light is bright enough, you're not going to read the glucose level, right? So the brightness of the place got to be right. Then the kind of lighting, right? The kind of lighting is important, right? A lot of people, and you see a lot of these people, the vehicles got this white light. Y'all seen that a lot, right? Very bad.
Yes,
I think
sir.
some of you, your vehicles have white light. I asked my nephew, why you buy white light, boy? He see everybody do it. Uncle, I see everybody do it. I said, but when you driving in the opposite direction, you blind me. You are a hazard on the road driving with white light. Because white light, right? We can't, the glare is too much for our eyes, right? And again, maybe later on, when we talk about light and so later on in the course, right? Reflection and refraction and so, you're going to understand that the brightness of those white lights are very harmful, right? Like the computer brightness, especially blue light that is coming from the computer is harmful, right? They found that it's harmful to the health, right? It doesn't make you want to sleep, and so you get sleeping problems. That's why nighttime sometimes your TV, if you can put on what you call the night light, so it's this yellowish light, right? And if you have this yellowish light like in your rooms, and so you tend to sleep, right? Because it doesn't awaken you so much. It's trying to mimic when the sun is going down, right? But white light tends to wake you up. White and blue light and so tends to wake you up. Whereas the reddish color, the orangish color light, what they call warm light, tend to cause you to sleep. So luminous intensity is a very important thing, right? Not just in well-being, traffic lights and so on, when your workplace, right? The kind of lighting that is used, whether it's sufficient or insufficient, right? It's very important. And what's the unit there? The unit is the candela, right? The candela. Yeah, that's the unit. And we'll talk about a little of it later on, and so maybe we can talk about how much is safe for you, so that when you're working or even in your home and so, the light levels is appropriate, right? You don't want to the light is too little and you're not seeing properly, right? A lot of people suffer from night blindness and so when they get older, right? And that's another problem by itself. Sometimes you wake up in the night and you flick on a switch. If you have a white light in your house, what happens? It wakes you up. Your certain chemicals in your blood is spiked, right? What was the one? Serotonin and one named melatonin. Melatonin is the one that make you sleep. I think serotonin is the one that gets you excited and happy and upbeat and so. I think so, right?
Yes, sir. Yes, sir.
So lighting in your
Yes,
house,
sir.
lighting at your workplace, very important, right? And so we'll talk about all of them. Good. So now that we talk about the basic physical quantities, we talked about the units they're measured in. And I mentioned that these units have what you call multiples and submultiples, right? In the notes, you will see what we call multiples and submultiples. Like you would have kilo. Kilo means 1,000 of something, right? So like if you have kilograms, it means 1,000 grams. You have kilometers, it means 1,000 meters, right? The second is a little funny. You don't say kilosecond, right? The second, this particular unit is the only unit that basically doesn't follow the base 10 system. You all notice that? That you have, okay, 10 mm equal to 1 cm. You know that thing? 10 cm equal to 1 dm. 10 dm equal to 1 meter. And then you have 1,000 meter equal to, but I got 10 meters and so on and so on. But let me go straight to 1,000 meter equal 1 km. You notice some multiple of 10, right? All of them have that. You don't hear that with
Kelvin.
like seconds, right? You don't hear it so much with amperes. You don't hear it so because such a large current might not be, you mightn't be able to experience that in real life, the Kelvin and even the mole and so, right? Even the candela, right? But they're more used with length and mass. But the second, in particular, they retain the imperial, sorry, the SI unit retained the Babylonian way of counting time, right? So you have like what? 60 seconds make 1 hour, right? As a matter of fact, there's something like this.
Minutes.
60 seconds equal to,
Sir, 60 seconds, 1 minute.
1 minute.
yeah, 1 minute, right? There's a thing like 60 minutes is equals to 1 degree, right? Yeah, there's a thing like that, right? But that's in measuring angles, But when it comes to time, 60 seconds equal to 1 minute, sorry, yeah. 60 minutes equal to 1 hour, right? So they maintain the Babylonian way of counting time, right? So that one is a little queer. And then they have 24 hours. They kind of move away from it now, equal to 1 day, right? Yes. And I think what happened that they said 24 hours 1 day is because they connected, well, the 1 day is the time that the Earth takes to rotate once, right? Roughly. It's not exact. And therefore they say, look, okay, all right, let me stop with this thing where we can't say 60 hour. 60 hours is not connected to anything really, right? Anything significant. But 24 hour corresponds to a day. So they moved away from the multiple 60 and they go to 24 hour equal to 1 day. So that one is a little different from length and mass, right? Electric current, you have like milliampere, right? You do have that. M with a big A. You don't write out the word. M with a big A. You do have microampere as well, right? some very, very small current might be flowing, you know, in a piece of circuitry. But you mostly have milliamperes, like in your little phone, computers, and so very small currents flow in those, right? But like in motors and like your large electrical appliances, you can have hundreds of amperes passing through them, right? And well, when it comes to if we're discussing health and safety and your general well-being, well, you have to be careful then, right? Because as we said, what you can't see can kill you, right? So there are some multiples and submultiples, and maybe what we'll do, I'm watching our time. Maybe what I'll do, I'll probably do some examples another day where we convert one to the other, right? I'll put together some examples and we'll do the conversion, right? We'll do the conversion of one to the other. Before we move away from physical quantities and the SI unit, you might be wondering, man, but sir, despite we talking about SI units and so, Guyana can't shake. Guyana can't shake. They don't seem to be able to shake what we call the British, the imperial system, right? Where we measure things like, okay, you measure length in, until now, you know, you get people coming to do work for me here. Even me, when I do measurement with the measuring tape, I still say, you know, 1 foot 6 inches. You know, I still say that, right? The way they measure wood, you know, they call BM, 1 BM. You all know how much is 1 BM, right? They still measure wood, right? Because 1 BM is like, okay, if you have a 12-inch piece of wood, right? It's 12 inch in width. It's 12 inches, right? And the length is 4 feet, right? So this is 4 by, it's 1 foot, right? 4 by 1, which is 4 BM, right? 4 BM. So how you do it, let me just tell you how you do it. I used to work very many years ago. I used to work with a contractor. So you measure the width of the wood, the length of the wood, you multiply them and divide by 12. So if it's a 6-inch wood and the wood is 20 feet, you do 20 by 6 divided by 12. So this is 10 BM. Right? Nowhere in this country you go where you measure wood in cubic meters. Cubic meters. That's how you're supposed to measure the wood. That don't happen.
Two of them is measure the logs in cubic meters.
Oh, they're doing it now?
The log itself, the whole
Oh,
tree
the
like
log
the
itself.
yeah.
Nice. I'm happy to hear that. I'm happy to hear
And
that.
the BM is 12 by 12 by 1. The thickness of the wood gotta be 1 inch.
Yeah, oh yes, oh yes, oh yes. I left out that. If the wood is 1 inch, yeah, 1 inch. Sorry about that, boy. It's the length by the thickness by the the length by the width by the thickness. I say, okay, this is a 1 inch wood divided by 12. If it's 2, it's a different matter. If you get 2 there, it's a 2-inch wood. This will be 20 BM. Thank you for that reminding. Yeah, I was reasoning it's a 1 inch thick. Yeah. Yes. 1 inch thick wood. Thank you for bringing that up. And I'm happy that they are switching to cubic meters, right? Because that is not being used for, I mean, generally. I have a couple of lumber yards near me here. If I go and tell the girl I want 10 cubic meters of lumber, I get a course and the girl cuss me up and chase me out the place. You understand? You say you're showing off, I don't know where you get it from, right? Same thing with kilograms. Who you go in the market, right? They're still selling pounds. You understand? They're still selling pounds, right? You still see it going on. And they approximate it because they know to set up the thing, right? Because 1 kilogram is approximately around what, 2.2 pounds, right? But they're not using the 1 kilogram thing. They're doing the adjustment so that you get less, sometimes either the 2 pound or less, never more. Yeah, so the imperial system, Guyana seemed not to be able to shake it, if I am to use that word, right? So we still measure things in foot, in inches, right? You're still hearing, you all know we don't say mass, right? In Guyana, we say the weight of the potato is 2 pounds, right? However, current and so, all right, they do use the ampere. Temperature. But I said I'm going to talk about the relationship of temperature and so. The imperial system, right? Let me see if I can move this away from here. But temperature, right? Temperature. The imperial system used centigrade, right? The Americans love Fahrenheit. But the SI unit is Kelvin, right? Is there in the notes any relationship that they connect? Yes, I think they did connect. The temperature in Kelvin, right? In Kelvin is equal to the
Excuse me, sir.
temperature. Yes. Yeah, go ahead.
Sir, so the SI, which is Kelvin, it is like universal.
It's really the unit of the sciences. When you're doing experiments and so, right, and you're reporting your findings or you're setting the conditions, you will not stipulate, right? I mean, a really hardcore physicist, chemist will not use centigrade nor Fahrenheit. They'll use Kelvin because some of the formulas were not derived with centigrade nor Fahrenheit inside. They were designed for Kelvin, right? I know that I think the note says 2.73.15. I'll leave out that 0.15, right? It's really the unit of the sciences, And then I think there's a relationship between degrees Fahrenheit and Celsius, right? And yeah. So this is what you're supposed to do. It's degrees Fahrenheit minus 32, right? Divided by the 9/5, right? Which is equal to 5/9, right? Or the temperature in Fahrenheit minus 32 degrees, right? So this is what you have to do. So now we can convert, right? Let me see if I can get it right now. So 80 degrees Fahrenheit will be what? 5/9. 80 minus 32. And that should give us our answer, right?
Yes, sir.
80 minus 32
It's
multiplied
48.
by 5 equal to that divided by 9. Yeah, around 26.6, roughly 27 degrees. And it does feel like that. It does feel like that. It feels a little warmish here where I'm living, right? So it's incorrect. Yeah, our formula was wrong, right? Our formula is wrong. Good. Yeah, so these are what we'll do maybe the next day we meet, and I think I'm getting to understand that Tuesday is a holiday. Is that right?
Yes, sir.
Our Tuesday is Pagua. So we wouldn't have a class. All right, I'll send you some notes more. And the next time we meet, we'll do some more conversion. Because this is not enough, right? We'll do some more conversion where we're gonna convert different lengths, one to the other, temperature conversion, and that sort of thing. Mass conversion. Just for you to get a feel of it, right? Yeah, Williams.
Yes, sir. Sir, so you can upload this recording before, right?
Yeah. And something I was going to tell you about before I leave. Oh yeah. Before we move away, and we cannot we talked about the basic or the fundamental quantities, right? But then there are what we call derived quantities as well, right? Derived quantities. And what are these? Just to give you a few examples, right? You have like, okay, velocity, right? Velocity is actually, distance, which is really a length, right? Traveled in a specified direction over time taken, right? So notice this is really a length, right? This numerator, and this is really time, right? So velocity is derived from length divided by time, right? Velocity is derived from two base units, right? Or fundamental quantities, right? So the unit for it, well, okay, just like how this is meter and this is second, velocity might very well be measured in meters per second. But again, at times instead of meter per second, like in your car, your speedometer don't tell you the velocity that you're traveling at in meter per second. You might have km per hour, right? How do we convert one to the other? Well, we talk about that, right? Then let's take another, just to give you a couple of derived units, like density, the very important one. Density. What's this equals to? Mass over volume, right? Mass over volume. Oh, by the way, I think I'm jumping the gun there. Volume itself, volume is a derived quantity by itself, because what is it? It's a length by a length by a length, right? And this is if you have a solid object, right? You can have volume that is okay, like liquid measure, right? And it's also in cm cube, right? But you can also have liters, right? Liters. And this is related to cm cube, like you have 1000 cm cube equal 1 liter, right? That's the equivalent, right? When you're dealing with liquid measure. You're dealing with liters, right? So yes, volume is a derived quantity because it's a product of three lengths, right? Length by length by length is the cube of lengths, right? So yeah, it's a derived quantity, and that will make density and also a derived quantity because it has a base unit in its numerator, but it has a derived unit in the denominator. So it overall density is a derived unit, and you can always research some more of them, right? And you will get to understand that density can be measured in grams per cm cube or kilogram per meter cube, right? Depend on the convenient unit that you're dealing with, right? So those are some examples of what we call derived units, right? So we got base units that are independent. They can be measured directly, right? Then you have derived units. Yes, there are instruments that can actually measure even derived quantities now directly. There are instruments like pressure. You have pressure gauges, right? And you can measure it directly, right? But a lot of the derived units, they come from, they are derived by some maybe multiplication, division. You have to do some mathematical operation to the base units to get a derived quantity, right? So keep that in mind. And then another day when we, and as we get in, by the way, but as we get into the various topics and so, we're going to be able to convert. And maybe that's another thing I have to consider in terms of timing and so, because if I take up next Friday to do conversion, it might cause some problems in terms of the timing of the course. But we are going to, as we do the topics, we're going to do a bit of conversion inside them so that you're able to see how to convert one to the other. Because if I do all at one time, it might confuse you, right? It might confuse you. So yeah, I think we have been able to introduce ourselves to the physics there a little, right? So today we talked a little about what physics is generally. We talked about what physics is, right? And we said basically, it's the study of the properties of matter and energy, right? Energy, right? And we talked about some broad areas that we're going to study in physics: mechanics. What we talk about, heat. We talk about light, sound, electricity. I'm not sure this course will cover magnetism, nuclear
Waves.
physics. I might have missed something here.
Waves, sir.
All right, waves is related to all of these here, right? Waves, yeah. But those are some broad areas, right? And they all have to do with the properties of matter and energy, right? And that physics involves, right? And I'm hoping that this little overview of physics, I didn't get into, this matter of theory and the scientific method and so, right? I didn't get into all of that, but those are things, if you want to do some reading, you can find out some more, right? Because in physics, you hear a lot about, well, I'm summarizing now, but let me not bring in anything new. Maybe next week, we'll talk about laws as against theories and so, right? We'll talk a little more about that maybe next week. If you remind me, I will talk about it. If I forget, well, yeah. And then we looked at fundamental quantities, right? And I think instead of this big word, basic quantities, right? And their units, right? We talked about your SI units in particular, and we alluded to the imperial or the imperial or British way of measuring certain quantities, right, before. And they seem to be so deeply embedded in us, you know. We're freed of slavery and colonialism long, but we just can't let go, right? We just can't let go. So they're still being used in all over you go, in business, in construction, even in your workplace. You see these units showing up all the time, right? So it's good to know a little about them and how they're connected one to the other, right? How to convert one to the other. And as we go along in the course, you know, you can, we'll cover a lot of them. And one of the things I always tell students, right? Most of the time, especially students who, you know, you're not going to be teaching high school students or even primary school students. Like when I teach this maths course, there's this maths course I teach. And they're talking about computation, and they want me to teach the students how to do long multiplication and long division. I said, that's nonsense. Why I say that is that today, let's say you are in you're one of, I heard some of you are you're working in medical field, like you're a nurse or you're a lab tech and so. And you want to convert cm to inches. What do you do? Cm to inches. What do you do? Anybody? So you're on the job and somebody says, man, the person is 167 cm in height. How tall are they in feet and inches? What do you do?
Multiply by
Sir,
2.2 something.
What you do?
The 167 is divided by 30. 30 cm is 1 feet.
Sorry, the phone got the calculator to do the conversion.
Who said that? Who said that just now about the phone?
Ricky.
Well, Ricky, you're a brilliant guy, right? I am not criticizing the other guy who knew, right? It's good to know, right? Because there are rare instances in your life when the phone will give up, the computer will give up, there is no power, and your brain will have to go to work. But for the vast majority of times in your life, right, we have our phones with us, right? And you wouldn't believe me. In this lecture, and I'm not lying to you, I don't like to show off and lie to people. While I ask you how to convert Fahrenheit to Celsius, you know what I do? I have another screen here and I click how to convert from Fahrenheit to Celsius, and the thing spits it out. 80 degrees Fahrenheit, and the internet spits out the temperature in degrees Celsius. We have the technology, right? You understand? I'm not saying the guy that answered about dividing by 30 and all of that, nothing is wrong with that. Very good. Very good if you have the thing in your brain, right? That's impressive. But for the rest of us who ain't got that good a brain, make use of the technology. You can't buy a $100,000 phone and it's useless, right? Quickly, and if you develop ability to typing quick, and nowadays I got a thing, right? Gemini. I got Gemini on my phone, and let me tell you, I ask Gemini everything, right? Everything. If I want to, the other day I was telling Gemini, I want to change my oil, not oil, coolant in the car. Gemini, how to do this? And Gemini spelled out. Look, I bought an array of capacitors, and I was going to connect it to my battery, and little did I know that the capacitor, when it's charging, because it will call for a large current, it's going to give a big arc and can spark and cause a fire and damage my eyes and hands. And so I didn't know that. So when I was going to do it, I said, you know what, let me ask Gemini. And I asked Gemini, I said, Gemini, is it safe to connect a capacitor to a battery just like that? And Gemini says no. And Gemini is a woman talking, right? For me, I chose a woman's voice, right? And she explained what I need to do to charge the capacitor safely and then connect it to the battery, right? So we have the power in our hands, right? So, like my friend who said, who gave me a quick formula, and he's very good, he has it in his brain, that's excellent, right? But then for those of us who can't remember that and who can't do the computation, we have the technology, we have our phones, we have computer, we got tablets, we got some people got smart watches, all kind of things. People got smart glasses now, right? So we can make use of it to do these conversions, right? Yeah, and then we talked a little about derived units as well, right? Derived quantities, sorry. And their units, of course, and their units, right? And we talked about some examples: velocity, density, volume, right? And you can even think, and any one of these things you see in the notes, right? Anything you want to do. We have come to the point, right? We have come to the point where you don't even need me to teach you certain things, right? The AI can do so much for you. You wouldn't believe me. You see those notes I sent you? You see those notes I sent you? I'm talking about the brief notes that you saw there. I gave the notes, you know that expanded note that I sent to you with a whole set of about 30-something pages? I put it in the AI and say, summarize this for me in just, just for the students. I explain, I give it a prompt, like, to summarize it briefly for the lecture. And you wouldn't believe me. The AI spit out, let me see how many pages. How many pages we got? 8 pages. Sorry, 11 pages. But if you notice, it's rather spread out, right? It's rather spread out. Oh, by the way, there is something there. What is it? Planck's constant. I think there is an error in how the notes came out. Let me just tell you, Planck's constant. Not that it's important for us, right? It's joules for, I don't know what it's supposed to be, seconds, right? I see they have J / C dot, what is that? PS? I think something wrong with the code, It's really joules per second, right? Yes. So it's joules per second, right? I'm sorry about that typo. I see it more than one place in the note, right? I see it more than one place. All right, yeah, good. So maybe we can pause there, right? We can stop there.